The broadcast is now starting. All attendees are in listen-only mode.
Hello everyone, and welcome to GridGain Systems webinar, Nuances of Machine Learning with Ignite ML. I am Nicole van Geleur and will be today's moderator. Before starting, I would need to conduct a little housekeeping. Can you raise your hand with the hand icon on the left of your screen if you can hear me? I see some hands, so we are good to go. On behalf of today's webinar presenter, thanks for joining us. I'd like to introduce our speaker for today. Alexey Zinoviev is an Apache Ignite contributor for GridGain System. If at any point during the webinar you have a question, please type it in the Q&A panel. Questions will be addressed at the end of the webinar. Please also note that your phones will be muted throughout the presentation. You've joined us today to hear about how to make a backup in a distributed system, nuances of machine learning with Ignite ML. At the end of the webinar, we'll close out by taking your questions. With that, I'd like to now turn things over to our expert, Alexey Zinoviev.
Okay, hi. I think we can start. This is a talk about machine learning module of Apache Ignite. I hope that most of you use Apache Ignite in production or for pet projects, I don't know really. But as I understand, not so many people know about different capabilities, about different functionality, which is presented in our machine learning framework. And I think this is the first webinar where I can present really new algorithms, really new things, and let's talk about that. Let me introduce myself. I'm Alexey Zinoviev, as Nicole said. Also, I'm a Java Big Data trainer, and previous day, some of you I know used Apache Spark in production, Cassandra, and etc. I think most of you related to different big data projects or different financial projects, and I want to say that in the last 2 years, I spent a lot of my time, of my free time, or my working time to contribute Apache Ignite ML model. And I want to talk more about that. Also, on the next slide, you can find a few contacts. If you want to follow me, you can write me on email directly if you have any questions about Ignite ML. Also, you could contact me via next resources like Twitter, like Telegram, and etc. But unfortunately, for most of you, all of them are in Russian because I'm write mostly in Russian. But it's not a problem to contact me, for example, via Facebook and GitHub. I will send link into the chat later at the end of webinar. If you are interested, if you have any question, you can write me there. Okay, let's start. A few words about Apache Ignite. I understand that you know more about that, but let's remind something. Apache Ignite is a memory-centric distributed database for caching, processing, transactional, analytical, streaming workloads, and etc. I think you know this official definition, of course. But in reality, from my perspective, for example, the Apache Ignite is like a Swiss knife for speed up of your backends. And it has so many features like durable memory, native persistence, distributed SQL with ACID transactions and joins. It supports distributed caching, indexes, and so on. And now it supports machine learning pipeline, all the data stored in Ignite. I will not waste your time talking about what is machine learning or what is deep learning, okay? I suppose most of you have taken some machine learning courses or use it in production. I hope I'm correct. And I hope that you used one of the machine learning frameworks that I'll show in the next slide. Look at the next slide. What logos do you see on this slide? You see from right to the left the following frameworks. Apache Mahout, it was an old Hadoop framework that supports a limited set of classical iterative ML algorithms. In the past, it was implemented via MapReduce approach or the Hadoop, and currently it's a strange set of distributed algebraic primitives that use Spark as the backend. I hope that in the new project you will not use Apache Mahout due mentioned limitations. The next candidate, it's Spark ML It's really distributed machine learning framework on the top of Spark core that totally converts data from core RDD or data frames to special types like vectors, matrices, and label points, and each algorithm implementations. And it costs memory and CPU cycles due to a lot of shuffling and Scala data mutability. Believe me, I worked with Spark ML a lot of time. H2O is a very interesting project. It's a memory platform for distributed scalable machine learning. It has a good integration with data stored in HDFS or Spark and Hive, and it's full of algorithms, but in reality, the deployment is really ugly from my experience too. I can tell that, believe me. And let's go to the right honor. We can see PyTorch, Keras, and TensorFlow, the group of deep learning libraries. PyTorch was built by Facebook. In addition to CPU, it supports GPU-accelerated computations. TensorFlow is currently it's like a main building block for deep learning. Totally, it's an ML and DL library, but the bunch of ML algorithms is poor, in my opinion. It supports many classical algorithms for classification and regression analysis, but it's not enough for real classical ML tasks. Deep Learning for J, it's interesting deep learning programming library written for Java world and the Java virtual machine too, but to run the distributed version of Deep Learning for J, it costs a lot of time or a lot of work of your DevOps, and it can has troubles with a very different dependencies on C++ written libraries. And also Keras. This is a popular high-level deep learning library which use various low-level libraries like TensorFlow, Syntk, or Theano on the backend. It's very interesting library, but from our perspective, for Java developers, you need a lot of time to start using Keras in your production. And of course, Keras supports most of deep learning algorithms integration, but it has no bridges to classical ML algorithms. Could it be trained directly on Ignite data? Yes, we can use one of the previous libraries like SparkML or scikit-learn to work with data stored in Ignite, but not directly. We should take data from Ignite and put to another systems. All the models should be trained and deployed in different systems, and the data scientists have to wait for ETL to move the data into a system like PyTorch or Apache Spark for a training purpose. And then data scientists have to wait while this process completes and redeploy the models in a production environment. It costs, and the whole process can take hours, moving terabytes of data from one system to another. And the Ignite ML, it was the answer on this problem. We are trying to train directly on Ignite data. The start of development of ML model a year ago was inspired by next ideas, by ideas of scikit-learn. This is the most popular data science library, which used widely in Python world. And I know that a lot of Java developers are trying to use it in one solution with Java backends. Scikit-learn serves as a reference point for the library in terms of functionality, and we want to have a build a Java library with an API that is adapted to a new version of Java, which can remind you scikit-learn standards, and this library must be able to run both locally as a scikit-learn and distributed in the Ignite cluster. ML module brings massive scalability for ML and DL tasks and totally reduce significant costs for ETL between different systems. Today, you can download only release 2.6, right? Because the release 2.7 delays, as I know, but today I totally told about new algorithms which I implemented in the news. We have no trouble with that. We delivered our algorithms a month ago, and currently we are waiting of closing of last bugs, as I know. Also, you can taste the new algorithms in night builds, for example, in master download, and I hope that in the next 2 weeks you will be able to download the 2.7 release and try directly new production our algorithms. And you should mention, you should understand that in the previous releases, we had implemented all algorithms via the common distributed algebra that did not take into account the peculiarities of algorithms. It reminds Mahout approach, if somebody of you used Mahout in production. But in release 2.7, the majority of algorithms are implemented via partition-based datasets. It's like RDDs and Spark, but has, of course, different internal structure. There, each partition has a special internal structure for each kind of algorithm or preprocessor. You should understand that we implemented special formats for different algorithms, which can be more optimal for that kind of algorithm, like one internal structure for linear regression, or for another internal structure for decision trees, or for SVM, and etc. Let's talk about partition-based dataset, our main structure. Apache Ignite now supports partition-based dataset, as I said, and this is an abstraction layer that sits between a machine learning algorithm and the storage and computation. And it uses a MapReduce-like operation for computation and cache backups for fault tolerance. And then I, for example, as a developer, implement new algorithms. I should put it into my mind, and all computation needed to be performed on a dataset splits on map operation, which executes on every partition, and reduce operation, which reduces results of map operations to one final result. It's very classical approach, but it works well for in-memory calculations without, intermediate backups into the disk, like in Hadoop world and etc. And also, in Ignite, a hash algorithm is applied to the k part of a k-value pair to determine that the value part is stored in a cluster, and the value part is actually stored in a partition. Partitions are atomic. In this slide, we can see, for example, a 2-node cluster with 2 partitions, P1 and P2. And every data set is spread across partitions in the start of training. And partitions hold a persistent training context and recoverable training data stored locally on every node. Apache Ignite Machine Learning is tolerant to node failures. So this is a new feature too. And this means that in the case of node failures during the learning process, all recovery procedures will be transparent to the users. Learning processes won't be interrupted, and we will get results in the times similar to the case then all nodes work fine. Machine learning algorithms are often iterative, and require context and data. This is a reason why we should think about recoverability, about node failure, and etc. I hope that you will not have such cases in your production with failed node, but we know that, I'm sorry, something happens. Okay, let's talk not about internals. Let's go to the ML algorithms. I briefly told about that. The 2.7 release will be published in 2 weeks, as I said. I hope, but I'm not sure. But you can find all these algorithms in master or release branch today. And currently, the framework contains enough implementations of classical machine learning algorithms and data preprocessing methods to be comparable with Apache Spark ML Lib. Yes, I could say it with honor. We in parity with Apache Spark. In this library, you can find such well-known algorithms as listed above, like logistic regression, SVM, KNN, INN. This is approximate version of KNN. It works more better with higher speed because it has a real training phase. If worked with KNN, you know that it was a very slow algorithm, but we speed up this algorithm with approximate version. The decision trees are supported. The different ensembles of decision trees like random forest are supported too. Of course, if you prefer to predict values instead of class labels, when we have a lot of regression algorithms for you, it works very well. For example, KNN regression, you know, very famous linear regression, decision tree regression, random forest regression, gradient boosted tree regression, and more and more and more and more. I hope that in release 2.8 we will have more regression algorithms. Ignite ML model is not directly a deep learning library, but of course we couldn't avoid a gentleman's set with neural networks. The distributed multi-layer perceptron has many hyperparameters and internally used, for example, in our logistic regression implementation, and it was a reason why we implemented multi-layer perceptron. If you has a not very complex task, not very complex data set, sometimes this kind of neural network will be enough. Of course, it's not real convolutional network, but for this kind of task, we have integration with TensorFlow. I will talk about this integration later. Of course, the sun will die before we implement all the algorithms from scikit-learn, but we could help data scientists with enormous data preprocessing on Ignite cluster side before sampling to Jupyter Notebook. For example, you are a data scientist and you have your separate Jupyter Notebook with scikit-learn and etc. But we could help you. We suggest a lot of preprocessing algorithms. If you are trying to sample from your Ignite cluster, use the algorithms, maybe without our ML algorithms. Of course, Ignite has such popular preprocessing transformations like normalization of vectors or different kinds of data scaling. For example, I know that standard scaler was merged this night for the release 2.8. It will be next release after 2.7, and a lot of different preprocessor are implemented in 2.7 release. It was only an example about standard scaler. We have another kind of scalars in our code base. Currently, the Ignite supports min-max scalar and max ABS scalar. You know that scaling it's very help technique which helps you with tuning of learning rate, for example, and it helps to your ML algorithms to work with data properly without different unbalanced without different weighted data, etc. Also, most of ML algorithms don't support work with string values, with categorical features. And of course, we are trying to solve these problems, and Ignite supports currently one-hot encoding and string indexing with a few different strategies. One-hot encoding is a representation of categorical variables as a binary vectors. For example, you have a column with different categories, and you should churn it and create a lot of binary vectors. That we will have one on the place which corresponding to the special category. Of course, we have different strategies to encode values for missed data, for max values, for mean values, and etc. If you worked with categorical features, don't worry, we support this regime. Sometimes it's difficult to evaluate how good this or that binary classification model. The first idea is splitting of initial dataset on test and train subsets. But sometimes we could get an effect of overfitting. And the next idea is k-fold cross-validation. It was inspired by scikit-learn library, but we implemented distributed versions of that. During this process, Ignite splits dataset into k consecutive folds, and each fold is then used once as a validation, while the k-1 remaining folds form the training set, and the k results can be averaged to produce a single estimation. Or you can get all scores and make other calculations with resulting array of scores. And we have a lot of different objects to help you build a model evaluation pipeline. We have in beta pipeline API. Maybe if we will have a lot of time, I will present you this beta API. Of course, we have not in beta, but in stable features: test train split, parameter grid, to tune hyperparameters of algorithms of trainers, for example, the binary evaluator, different binary classification metrics, and of course, with cross validations, it helps you to tune hyperparameters of your trainer. Or in future, we hope that we will help with tuning of hyperparameters of different preprocessing stages. But it will be in future releases. Ensemble, let's talk about that. Ensemble methods are meta algorithms that combine several machine learning techniques into one predictive model in order to decrease variance, its bagging, bias, its boosting, or improve predictions, its taking. And currently, the Ignite supports only boosting. The bagging in progress, it will be in release 2.8, and staking on the roadmap. I think it will be Ignite 3 or later. But you can start with bagging, or I'm sorry, with boosting, to boost a few models if you need to create ensemble models. Let's talk about superpower features. I think it's real superpower features because not many ML frameworks have them. Ignite ML community, in Ignite ML community, we experiment not only with classical ML algorithms, but with the different advanced meta techniques, which helps to join different models into one. And one of these techniques is one online mini batch learning. It's real model updating. It's implemented for the majority of algorithms, and it gives to users ability to make online learning pipeline. For example, if your model was training on the first part of data set, and after that, from the data stream, we added a batch of data. We can train on this batch and join to model by the special aggregation law, which is implemented for each algorithm. I know, for example, in Spark, the online learning is implemented only for 2 or 3 algorithms. In our case, we support that for many. For many algorithms, I think maybe for the majority, like 80 or 90%. Also, the next great feature, this is a TensorFlow integration. TensorFlow on Apache Ignite is a tool set for deep learning that allows to utilize all TensorFlow functionality and distributed nature of Apache Ignite at the same time. And TensorFlow on Apache Ignite consists of 3 major components. Ignite dataset that provides an ability to feed training data from Apache Ignite. The GFS, oh, I'm sorry. I'm sorry. EGFS plugin, we told about the EGFS plugin, right? That allows to use Apache Ignite file system for checkpointing and communication with TensorBoard, but maybe in future we will drop EGFS support and we'll use our internal file system for IgniteML. To store this data for checkpointing. But we support the feature of checkpointing for communication with TensorBoard. I think it's very important. And the distributed training that makes it possible to run different model training instantly inside Apache Ignite cluster to minimize data transfers and provide so-called zero ETL. Also, you can look that our PR pull request is merged to TensorFlow. You can find our contribution in TensorFlow contrib ignite package. It works with 1.12 TensorFlow, and we discussed it with TensorFlow committers. Our functionality, where Ignite dataset is supporting, will be merged to the TensorFlow 2.0 without any issues. And you, for example, to download Anaconda package, if you're a Python data scientist, and use our, if you have Ignite cluster, use our Ignite dataset to grab the data and train on them in TensorFlow, for example. But I think that in future we will have more interesting cases for distributed training to present you on the next webinar. I hope it will be my friend Anton, who developed a lot for this integration. Also, we have different issues. Then we developed our IgniteML module. I know that this is a webinar where I should told a lot how it's. Of course, we are developers. We have many issues, and in this chapter we've discussed possible issues that are solved by IgniteML developers from time to time. You should know about that. I mean, it's not bugs; it's issues for developers. The first of all, for instance, we have a lot of time. We should spend a lot of time to think how to implement different algorithms. And for instance, to multiply two matrices, you could split them on stripes or blocks and execute it in parallel or in distributed mode. But if data are not stored properly in Ignite cluster and it involves a lot of bandwidth operations, sometimes it's crazy. And as I said, this approach was used in previous releases. For example, if you used our ML in 2.4, 2.5, you can have not very high rates of performance on different matrix or algebraic operations, but we improved this solution. We drop the slow algorithms, we drop algorithms which could not be distributed well, and the implementations currently very fast, but we should understand that not all algorithms, for example, from scikit-learn, can be theoretically distributed. There is no mathematician papers, there is no mathematician works how to distribute these kind of algorithms. And sometimes we could suggest not the exact version of or analog of scikit-learn algorithms. We are trying to distribute algorithms, but sometimes it can be an approximate version, which can give for appropriate time the slower accuracy, but it will be, I don't know, 2 or 3% of accuracy comparable with scikit-learn algorithms. But we put all these informations in the Java doc. If sometimes we have approximate version of algorithm, you can find this information in Java doc, in our documentation, on the Apache Ignite and etc. We don't hide this information. All these things we are doing for speed up of algorithms. Also, we should understand that the high speed up is limited due to the nature of distributed and concurrent calculation. I just remind you about one interesting law in the world of parallel computing. In computer architecture, Amdahl's law, or Amdahl's argument, it can be known by this convention, is a formula which gives the theoretical speed up and latency of the execution of the task at fixed workload that can be expected of the system whose resources are improved. And imagine that network shuffling doesn't involve significant costs and sharing data costs zero. And all these lines are upper boundary lines for the max speedup of many of our ML algorithms that are included into our framework and could be included in future. And part of algorithms, I should repeat that, could not be distributed effectively with linear scaling, for example, and you should keep in mind that fact. We are developers of ML module. Every day we decide what algorithms can be included, can be distributed, and sometimes we should drop ineffective algorithms. For example, if the performance of them is too ugly and couldn't be executed well in Ignite cluster. Sometimes it happens. Also, each ML developer, not ML user, I mean, should implement a new ML algorithm step by step. Developer has a choice what should be distributed or should be consequent. And if all algorithms will be consequent without distribution for many nodes, it will be a local algorithm which can run only locally. And for example, we dropped one release ago fuzzy Kamins algorithm, which was included in our code base due to very bad performance, very bad annotation, algorithm complexity, and etc. Also, of course, all Ignite ML developers and Ignite ML users should keep in mind the algorithm complexity in terms big annotation, as I said. And in ML area, we should estimate complexity both training phase and prediction phase. And there are few examples of ML algorithms training and prediction phases complexity in this slide, and all algorithms presented this slide are implemented in our library. To know more about that issue, I highly recommend next paper. I will send links into the chat. Couldn't copy paste into the chat now, but I will provide a link later. Also, if you are interested in contributing into open source project, you can ask me, write into developer list, or I don't know, ask something on user list. Also, Apache Ignite community is too large. Today it has around 200 contributors totally, 8 contributors to ML module. And you can find a few community talks in our contact group if you know Russian, or read our blog posts, read Ignite documentation, read ML documentation especially. But believe me, the best kind of documentation are our examples. Our examples, especially for ML model, are really good. You can run separate examples. You can run our tutorial. I prepare a tutorial especially for ML module, and we will run 3 or 2 examples from tutorial today. I hope we will have enough time for that. And also, I will put 5 cents about roadmap for Ignite 3. I hope that we will implement a special NLP module. Also, it will have more integration with TensorFlow. It will have more clustering algorithm like LDA, bisecting K-means, maybe DB scan, and etc. I hope that real cool statistical package to calculate variance, to calculate correlation, etc. will be merged in Ignite ML module. We will add more algorithms for dimensional reduction, and also we prepare a lot of tasks for beginners. If you want to join us like a contributor, please write me. As I said, we have special short small tasks for you, but if you want to contribute more, we have a lot of plans in our roadmap for the future. Okay, let's switch on the demo. I've prepared a special demo with a few the idea. I will switch on that.
I apologize to everyone who seems to have lost Alexey. Alexey, are you there?
Yeah, just a second. I need to switch my display. I hope that you see the code.
Yes, we can see. That's fine.
The code?
Yes.
Okay. Let's continue. We will start from the file with the data about Titanic passengers in CSV format. A second to open that. The data set for this tutorial was taken from the famous Kaggle competition, and you can find this data set here. This is Titanic CSV for, as I said, 1,300 observations. Each observation has 14 columns, and some data is missed, of course. And we are trying to repeat Kaggle winners and do that with Ignite library. And I will show you how to train the model on this data set. Okay, let's go to our tutorial. This tutorial could be found in examples. You could find here ML chapter and the special subchapter with name tutorial. It has a lot of steps. I will go deeper only 3 of them. And let's start from the data loading. We will use reading from the CSV file. In reality, of course, you will read from Ignite cache or from Ignite database. I don't know which API you use in production. But here, we should load the data into Ignite cache using special rendezvous function and a very simple cache configuration. And it will have 10 partitions due to the information from rendezvous affinity function. And okay, we will use a decision tree classification trainer to predict death in the disaster. Let's extract 3 features. It will be features from column 0, from column 5, and from column 6. We will use special feature extractor. This is a typical Java Lambda. We will use vector utils function to package the data from simple doubles to our internal structure like a vector. And this is a Lambda. The next Lambda is a label extractor to extract class label, of course. We should define Ignite B function. The next types, integer, array of objects, and double to extract from the position with index 1, our label 0 or 1 for passenger who will more successful than another. And in the next row, here, you can see decision tree classification trainer with simple settings like a max dip of trained tree and min purity decrease 0. Don't put in your mind these parameters. It's typical parameters for this algorithm. And in the next position, after that, we will train the model based on the specified data using decision tree classification, as I said. We will combine together our Ignite cluster. You can see how we define Ignite variable, our data cache, which was populated by Titanic data, our feature extractor, and our label extractor, and feed to the data our trainer. The resulting model could be used for evaluation. And this example uses evaluator, special object, which has a method evaluate, which combine together data cache with data, our model to evaluate this model, our feature extractor and extractor to repeat extraction from the data cache, and, for example, simple metric. We will use accuracy. I hope all of you use accuracy like the most simple metric, the simplest metrics which can be used for estimation, like the proportion of right answers to the amount of all answers for your model. And we will print the result. We will print the accuracy, and we will print test error like a 1 minus accuracy. Let's run this example and look into next window. A lot of information which was printed from the Ignite cluster, from the Ignite topology, for example, Ignite settings, and in the last rows we can see the resulting information about our ML training. Please wait a few seconds, because I'm running it not on the SSD disk, but in hard drive. Okay, we could find here accuracy with very high percentage, because we use only three simple features from our Titanic data set, and very low test error. I think that's enough for first run. And also you can find here practice look for the decision tree model, the bunch of different if else's. If you used decision tree in productions, it can be very good copy pasted, and with I don't know, simple minor changes could be merged into production like Java or Scala code and etc. But okay, we can see the decision tree model. The good accuracy, but it's not enough for us. Let's go deeper. We will use imputer trainer to fill missing data presented as double none values in the chosen columns. We have not so many this kind of data, but imputer trainer it's very interesting preprocessing step. We can look into the next example. Just a second. Step 2, imputing. As I said, you can find that on the GitHub or in examples. We should define imputing preprocessor like a result of imputer training on the Ignite data which are stored in data cache. We will extract the same three features, but the resulting training is the composition of feature extractor and imputing preprocessor. Look here, the difference with the previous example is usage of imputing preprocessor instead of feature extractor. In reality, it will be a composition of two lambdas. This is the first lambda. This is which includes feature extractor, which is defined earlier here. And here we will use imputing preprocessor. If you will have more preprocessing stages, you will have the same composition. You will add more preprocessing stages here, and the last preprocessor should be passed here into this parameter. We repeat our training and our evaluation. There is no difference in this code. We use the same evaluation. And please wait a few seconds to see how accuracy was changed. But unfortunately, we will have not so many missed values, and the imputing technique will not improve our accuracy, I don't know, very big. Maybe we have improvement something here, but in reality, not real percentage. It's very interesting technique, but we should start to use our one-hot encoding to encode different categorical features, which could really improve our model. Okay, let's go to the next example. Step 3, categorical with one-hot encoder. Here we will use the composition of two preprocessing steps. First of all, in feature extractor, we will add new features. For example, the feature with name embarked, the famous feature with sex of passenger, and here we will define one-hot encoder preprocessor as a result of encoder training, where we should define encoding type, one-hot encoder, all encoded features. For example, we have 3 categorical features, and we'll use encoding for them with encoded feature 0, with encoding feature 1, with encoding feature 4, and call the feed method to get the one-hot encoder process. The resulting one-hot encoder preprocessor will use as a parameter for next preprocessor, imputing preprocessor. And the resulting imputing preprocessor will used as a parameter for final trainer. Currently, we have 2 preprocessing steps and 1 final training steps. In our pipeline, we have 3 stages, and we have same code for evaluating. Let's run. And I hope that new decision tree model will be really bigger than previous. It will be really more complex because we have more features, and the accuracy will be higher. I hope it will be around 80% or something else. Okay, let's wait a few seconds. Currently, you can see that we run our algorithms locally, because in our topology snapshot, we could see only 1 server, but you can add more servers in our topology, and it will work fine on different topologies, like with a few servers, etc. Okay, our accuracy is higher than in previous example, and the categorical one-hot encoding really helps us. Okay, and let's go to the last example for today. In this example, will be added a few preprocessor steps: min-max scaler, normalization preprocessor, and string encoder preprocessor, and etc. It will be very long and complex preprocessing to get final data to train on them, but don't worry, it's not a very large piece of code. Okay, let's go to the step 7. We will miss a few steps. In tutorial, if you want to run all of them, you can go and download this code from the GitHub, for example. And look here, we have, first of all, feature extractor, you know that, label extractor, you know that. We have more features, passenger class, CBSP, part, sex, embarked, age, and fare, for example, fare of ticket. Also, we will use next technique like train test splitting to evaluate on taste dataset. It's a very good technique, as I said. Before that, in the previous example, we evaluate on the same dataset, and we can get an effect of overfitting. We will learn all stuff from one training dataset, but the validation is poor. And also, we will have string encoder preprocessor. This is another kind of string encoding without producing of binary vectors, only with re-enumeration of data. Also, we will have imputing preprocessor about the string encoder preprocessor, min-max scaler preprocessor, which has imputing preprocessor as a parameter, normalization trainer, with min-max scalar preprocessor as a parameter, and etc. And as the final stage, we will have, as in the previous example, the trainer. But look here, in our model, we will have a special filter to get train dataset. From this filter, 3 parts of 4 to train on them, and 1 parts of 4 to validate on that. For example, here we will get train dataset, but to evaluate our model, we will use test filter to get test dataset. Because it's Java, we have a lot of lambdas, we have a lot of different functional interfaces, and etc. All our API is developed for Java 8 and higher. But sometimes it looks strange for people who don't work with Java 8. Also, we will run the last example and we'll get accuracy, but it will be not accuracy, I should remind, on the whole data set, but only on test data set. And maybe it can be lower than in the previous example due to the overfitting in the previous example. But it will be enough high, I hope. Please wait a few seconds. And of course, sometimes it's crazy to understand how to join all these preprocessors, all these kinds of trainers to one pipeline. And we are developing the special pipeline API. I will open the example with this API to present you, but this API only in beta. You can experiment, you can play in the sandbox, but it can be broken in the future releases. Okay, we have enough high accuracy on the test data set, and I think that that model is enough good to predict a lot of passengers in this very famous disaster, like Titanic disaster. Okay, and in the end, as I said, I will present you pipeline API. Please look into step scaling with pipeline. You can find here special pipeline object where we could add bychain methods: feature extractor, label extractor, preprocessor, and different preprocessors, which will be organized into one line. And the trainer is the final step, and can call feed on the whole pipeline to get the pipeline model, which pipeline model can be evaluated. Okay, I think that's enough code for today. Thank you for your attention. I hope that the presentation was interesting. If you want to know more, please write to GridGain. Please write for me directly. If you have question how to use API, please post your question on the user list. I will wait it. I really wait questions of new users, and I hope that we can start work with Ignite ML in the closest time. I mean the new release. Thank you.
Thank you, Alexey. We'd like to give you the opportunity to ask some questions to our expert, Alexey. So type your questions in the Q&A panel now, please. We have one question, Alexey, at the moment. The question is, how do you compare it with respect of VoltDB in terms of performance?
Oh, it's a good question. I think it's a question related to the whole Ignite. I mean, we should compare Ignite SQL, for example, or Ignite Core with VoltDB, right? I have no experience with ML about the VoltDB. This is new information for me. But if you will give me time, I think we can make a benchmark for that. I mean only ML algorithms, but I'm not sure that WorldDB has these algorithms, this kind of algorithms. I'm not sure. If you ask about common performance between WorldDB and Apache Ignite, we can, if you leave your email, I could ask my colleagues from the SQL team, and we can send you results if we have the same benchmarks. I hope I answer your question.
Thank you. The next question is how to solve multi-classification tasks using Ignite ML.
Oh, it's a great question. Thank you. Currently, we have only two algorithms which are supported multi-classification. It's logistic regression, multi-classification logistic regression, and multi-classification SVM. But in the next releases, we are going to develop the common technique, meta technique, to use one versus rest approach to use all kind of trainers to predict, using binary trainers to predict different cases in multi-classification tasks. I hope that it will be accessible in release 2.8. But of course, we should wait release 2.7 to get a lot of our current algorithms. Thank you.
Thank you. So we have time for one more question. And that is, where can I find code examples that have been demonstrated today?
Oh, okay. I will share on my browser. Give me a second. Just a second. Look, this is Apache Ignite GitHub, right? And you could go to the Ignite examples, blah blah blah, src main Java org Apache Ignite examples, and etc. And here we have a lot of different examples in ML subchapter, and here you can find our today tutorial with a lot of steps. The first steps like read and learn, imputing, scaling with a pipeline, examples of cross-validation usage, of split train test usage, of log regression usage, and etc. And also, you could follow me on GitHub. My nickname is Zalislav. You could follow me here, or you could follow me with the same name, Zalislav, on the Facebook. You can write me there directly if you have any question. But the best choice here to post your question on the user list, the stack ML, if you have any questions with running examples and etc. Okay, thank you for the question.
Thank you. That is it for today. I want to confirm that this webinar will be available on demand starting tomorrow. So if you want to review it in your own time, you will be able to do so. And in the meantime, I would like to thank our speaker today and thank each of you for your participation and for joining us. Thank you. Have a wonderful day. Bye-bye.
Bye. Goodbye.